Hi, good evening. A very good evening to everyone out there. Uh, this is Vinod Kumar, and for the next 1 hour, we are going to discuss about this thing called microservices and with a technology called Springboot. So, before I start what it is and what microservices is, what Springboot is, let me quickly brief about myself. I'm Vinod Kumar, and I'm an IT consultant, and I deliver corporate trainings as well as I also provide technological solutions for various corporate companies. And my overall experience is 12 years, and my core technologies include Java, Java Enterprise Edition, Spring, and I'm into UI as well. I do Angular, React, and I specialize with .NET as well. And this is about me. And this session is completely going to be about, I mean, it will be giving you an exposure about what microservices is and how Spring Boot as a technology lets us create, uh, support, whatever with microservices. So before I jump into Spring Boot, I just want to give you a general insight about microservices. Microservice is not a term which is particularly related to one single technology, as most of you might be knowing it already. It's a general term. It's an evolved term. It's not something created and then implemented. With time, the term has been evolved automatically. Um, so let's discuss about it. But before that, I just want to tell you what we are going to see in the 1 hour span, because the expectations has to be right. So I'll be just giving you the insights about microservices for the first 30 minutes, and after that, for the next 30 minutes, I'll be telling what Spring Boot is and how to get started with Spring Boot. And practically speaking, it's not possible to get completely or drench ourselves into Spring Boot, but we'll be just introducing with the world of Spring Boot, the key terminologies, how to get started, how to run it, and what is possible with it, what is not possible with it. This is what we are going to see. The first half an hour is going to be about microservices in general, and the second half an hour is going to be about microservices with Spring Boot. That's how it is going to be. Okay, let's jump into the stuff. So the first thing which we are going to see is a thing called microservices, a combination of two words. The word micro itself is telling you a story. It has to be small. Don't think big if you are doing microservices. Keep it minimal. That is the main motto of going behind microservices and services. What you are doing is not creating a complete application or something. You or in a computer world, services means something which helps other applications or other services. There might be other services which might be need of some data or some kind of activity, or there might be some application, some UI which might need something. So anything which will be serving something to other in terms of data or in terms of information or in terms of storage, we actually call it service. So if a service is doing something at a minimal level, we call it a microservice. And the ideal thing is one should not make it big, but unfortunately at most places they quite make it big, probably misunderstanding the idea behind it. But if you have to stick to the real meaning of it, it has to be always minimal in nature. So that's why I say, when you're talking about microservices, when you want to implement microservices in that service, whatever you are trying to build, always do one thing and do it properly. That's the philosophy behind it. Don't get too many things into it, don't do too many things into it. Again, I repeat, what we are going to do is a service which is minimal in nature. So that seed has to be kept in our mind before we jump into this technology. I won't say this is a technology, this is an idea. which can be implemented with the help of various technologies. All the major technologies in the market, you can implement microservices. This is an idea, and this is an idea not created in a particular person's mind or something. With time, automatically the IT industry has evolved, and microservices also evolved. And recently, few years back, they kept the name for called microservices. It's not that somebody planned microservice and then somebody implemented it. Already microservices was there, they just gave the name. That's you have to understand. So let's elaborate and let's discuss and even further. So the thing is, it has to be minimal in nature, right? So when I start something, I have to appropriately and properly define it. Without defining it something, or without giving a proper insight about it, one cannot get it. My thing is, if you search the internet and if you try to get a proper definition or a proper understanding of microservices, you will not find anything standard. I mean, there is no standard definition for microservice. One cannot define it with a standard sentence or standard thing. It's about perspective, how one see microservices as, and at various places you will find various kinds of discussions about it. So I too try to find at various places and various things. And if you have worked with microservices for a very long period or some period, you automatically can understand certain things which microservices do and microservice architecture which particularly do. Microservices architecture in the sense how you particularly create various microservices. If I write MS, please understand this is microservices, and how they work as independent unit and how they serve to some common unit. UI means some UI is consuming, that way you can assume it. So my point is, things that are common to microservices is whatever I have underlined here. So you might try to read it, but I just want to give you the meaning of each and everything which I have underlined with proper insight. First thing, whenever you are doing microservice, the first thing you need to do is, if you want to do a big application or a big solution for your organization by following microservice architecture, if you have decided to do so, make sure it's a collection of small services. So in any microservice architecture, the first and foremost thing is, you will obviously find a lot of small services which works as independent units and which collaborate together to form a solution. See, for everything there is going to be a story, there is going to be some history. So there used to be something called monolithic architecture in the industry, and with time one more architecture has evolved called service oriented architecture, which was very famous few years back, still famous of course. And right now the catching term, or almost the term which caught the market, is the third one called microservices. So if you want to do a project or if you want to do an application, the approach differs in each approach. In monolithic you do it in a different way, in service oriented architecture you do it in a different way. In microservice architecture, you divide things into as small as possible and as independent as possible. Give me a minute, I'll show it. See, in a monolithic architecture, I'll come back to the original page where I was talking about microservices after explaining the word called set of small services. See, in monolithic architecture, the whole business or logic of your application is gathered at one place, and the whole model DB layer of your application is gathered at one place, and everything which you have built as part of your application is gathered at one place. So it's kind of a single unit where everybody involving in the project needs to know everything involved in the whole application. So in one way it is advantageous because everybody involved there knows everything about it, and since everything is tightly packed, there will be a proper integration. You don't need to suffer too much to integrate things. because already it is tightly integrated. But the problem is it suffers when you want to add new things, and when you want to add new things without disturbing anything. So such kind of things, it suffers because you almost tightly coupled everything in this kind of approach. We can talk even deeper about it, but considering the time what we have, I'm just giving you information at a very top level. And then came service oriented architecture. In service oriented architecture, instead of putting everything at a place, maybe I can come up with couple of services which might be doing a specific task. And if you see, end of the day, I am again making it a bit of monolithic thing. I gather all the services at one place, I integrate them at a point called enterprise SVC bus, means service bus, which integrates all of the things, and finally it will be consumed by the UI. So you're just decomposing works which happened in monolithic to a bit, but end of the day it is also getting integrated at one point. So when you are integrating at this common point, again you have to invest a lot of time in integration and understanding the project. End of the day, everything merges at one point, that you have to know. So the independency of this unit some way damages, because end of the day it has to meet at one common point. So when they meet at one common point, they should not disturb it, right? Obviously. Whereas the last thing, the current thing in focus, microservices, how we do a particular application is, suppose the end user is the one who is going to get the solution. This solution might be accessed through an UI, but this solution is not coming from a single source or a single service. N services, and always not database is going to be the only information source. Maybe it might be some mail server, or it might be some ERP system. Don't assume it to be DB always. It can be other things also. So a particular mail server may be concentrating on particular issue. All of them will be working as independent units, and end of the day they are going to meet at a common point. And this microservice doesn't need to bother about this microservice doesn't need to bother about this is going to be an entirely independent unit. This entirely independent unit is going to be straight away consumed by, not only in UI, most cases it can be another service or another application. There can be n layers. This is a simplified picture, but in reality the consumption of this microservices can be at various levels. Even a microservice can be consumed by other microservice also. But what I am trying to prove from this is, a microservice should be something minimal and independent. See in this picture, that's what it says. Monolithic, everything gathered at one place. Service oriented architecture. If you are separating it, you are separating it like a coarsely grained thing. Whereas this is microservices is finely grained. It's almost like a powder, small units, small entities, which makes a big entity. So you have to grain it as fine as possible in microservice. That's the simple meaning. So we got to know about the first thing. It's a suite of small services, small things. And second important thing is, it works with its own process. That thing you have to understand. For example, many people who are following this session, maybe you might have worked with web applications in Java. Maybe you might have seen you'll have JSPs, EJBs, servlets, and all this. Every unit which you build, end of the day, it's a very big unit, goes into the control of maybe Tomcat or some WebLogic or some kind of server. And no unit, I would say this JSP is a unit, this EJB is a unit, or a collection of whatever the application which you build or a service which you build is a unit. End of the day, that unit, whatever you build, is not independent. It is dependent on the container. You are giving your code to the container, and from then on, if you add few more JSPs as part of your application, few more servlets as part of your application, even this guys also need to get integrated here, and they are not going to be independent. Further, they are going to be submitted to the same Tomcat. So almost everything you build as part of your solution are dependent, and end of the day they are going under the control of a middleware or an application server like Tomcat, like Glassfish, like WebLogic. So the services or the applications whatever you build is not independent in mostly in my monolithic architecture and service oriented architecture. They are not individual process, whereas in a microservice every service which you build is actually a separate process which runs of its own. I'm not using the word separate process, own process. It handles itself. It doesn't need anybody's support. Whereas in a traditional application, it needs support of some external server. Whereas in case of microservices, everything it does of its own. It is not dependent on anybody. And basically, for communicating, I mean, a service, if it wants to communicate with another service, or if an application, if it wants to communicate with a microservice, we usually use a lightweight mechanism, a lightweight protocol. We won't be writing heavy code. We might not be exchanging heavy messages for communication. We simply use a simple protocol, not always HTTP. I'm giving an example like HTTP protocol. Simple mechanisms are used for communication. And as I've been right from beginning telling you, it's going to be an independent unit and it is independently deployable or runnable. It doesn't need anybody else support. You don't need to place it under the control of anybody. It runs independently. That's what you have to understand. And mostly even the deployment happens with a kind of tools, continuous integration tools, this DevOps mechanism. It almost lets us do fully automated deployment, and it always concentrates on the business requirements, business capabilities, whatever the requirement, the real-time challenge that is being posed on, microservices are capable of addressing it. And surely you have to understand a microservice has to have a particular focus, a single focus. It should not concentrate on too many things. For example, you want to create an API related to employee, just concentrate on that. You don't concentrate on messaging thing, you don't concentrate on some other thing, just concentrate on a single focus. And there is no centralized management at all, because if you build n microsystems, maybe if you want you can monitor them at one point, but in general even if nobody is monitoring them, they can actually run independently with bare minimum. I won't say there is no central management. You can actually monitor the servers, what they are doing, what is the process running, how much memory they are consuming. Everything is possible, but you have to implement it. So there is a bare minimum of centralized management for microservices. And advantages, for example, microservice 1 can be written by using Java, maybe microservice 2 can be written by using Node.js, and maybe service 3 can be written by using Python. Whereas in monolithic architecture you don't have that liberty. If you take something and if you want to build it in monolithic architecture, you are sticking to one technological stack, whereas here you have complete independence over choosing variety of languages. If you want to start something, you can start quickly and you can run it independently, and you can integrate it with the existing system, and it works as an independent unit. And even the storage technologies also, for one service I can use MySQL, for one service I can use Oracle, for one service I can use a NoSQL database, but end of the day they are finally serving for a business purpose. So you have lot of liberty and a lot of advantages when you go for microservice architecture. So before I proceed further and before I move into further things, further deeper discussion about microservice, the things which you take from this last 5 minutes or 10 minutes of discussion is, it has to have single focus, it has to be minimal, it has to be small. First of all, remember, if I say the word microservice, actually you are building a small project. That means, and that small project is independently runnable. And how are you building that project? By using some technology. It can be Java technology, it can be .NET technology, or it can be Node.js. So you are building an application you are okay to build even a bigger application with lot of things which it focuses, but remember, don't do it, make it minimal. That's what the whole idea communicates. And when you do like this, it has its own advantages and various things which we have understood is you don't need a central management, or you don't need to depend upon an application server for deployment, or you don't depend upon a central process which monitors everything. No, every unit which you build is independent of its own, it runs of its own. That is the idea behind any microservice. So the key things which you need to, whatever the things which I've been discussing for the last 10 minutes or so, this is explained with kind of technical words. Always it should be microservices. What microservices focuses? What is the idea of microservice architecture? So when you are doing a solution by using microservice, you need to decouple it. That means you should not gather everything at one place. Make as many independent unit as possible. Make them individual component. You know what is a component? For example, if you take a car is a collection of various components like tire, wheels, steering. Each one is a component. It makes a car. Likewise, if you are providing a software solution, make it into small units and make them work together and achieve a bigger purpose. So you have to componentize your application, and you need to focus on the business capabilities. The word autonomy is very important. Every microservice should be independent. It should not be depending on somebody else to run, or it should not be depending on a middleware to manage it. So nobody manages it, it manages itself. That's what you have to understand. And it has to be continuously deliverable. It should be integratable with the various CI systems which are available now in the market. And instead of saying responsibility, it should focus on single responsibility. That is a common word used in microservice architecture. So generally when you build a microservice, you tend to focus on single responsibility. And as I told in the previous discussion, you should not be actually managing with a central place for monitoring it. Governing services can be decentralized. You can be managing the services. That means you can get the metrics of it, how it is running, what memory it is consuming, in a way, whatever way you want. It's up to you. There will be no central configuration or central monitoring of it. If you want to do it, you can do it. You know the meaning of agility. Agility is you should be always fine for the changes that is coming in. For incoming requests or incoming needs, automatically you should be able to manage the things and come up with a solution with time automatically. So microservice architecture automatically lets you be agile. So for agile model, this is best suitable. So obviously whatever we have discussed in the past discussion matches with all this terminology. So whenever you are doing something with microservice, you have to make sure that it is falling under all these categories. So if you are slightly moving away, even though you are assuming that you are using microservice, but end of the day you are not doing all this, it cannot be called as a microservice. So microservice is a conceptual idea. Nobody can sit with you and monitor whether you are following all the microservice principles. It is the responsibility of the programmer, or it is the responsibility of the team to make it work like a microservice. You take microservice or architecture and you do big things, and you do hundreds of small things into one microservice. That is not going to be a microservice. Always make sure it is actually doing a single responsibility. So that's it about us. So this is a big picture in real time. If you are actually building a real world solution by using microservices architecture, how the application architecture overall will look like, right? There will be a content delivery network. I mean, you might be using some web server or something which end of the day delivers your content. You might have static content as well as some dynamic content which is being produced by various services at various points. And as I have just told you few minutes back, just even a minute back, that it has to be taking up a single responsibility or a very small responsibility. So like this, there will be n number of microservices which might be working independently. So end of the day, you might be calling them at one common point or a couple of common points. It's not that if I say API gateway, it's not going to be always integrated or called at one point. It's actually going to be n layers. If you see the real picture, you'll actually understand. It depends. No project or no solution is always same. Based on the business requirement, it actually changes. That's why we use the word agile. It changes. But my point is, the extra thing which you have to notice is, when you have n services running, the downside of it is, or disadvantage of it is, it is very hard to track what service is doing what and where it is running, where you have deployed. So suppose for achieving a business solution, say you have developed 100 microservices or 50 microservices, you deployed at various places, few services at our own servers, few services at AWS, few services at Azure, various cloud places you deployed it. End of the day, tracking them all is always tedious, always a problem to comprehend the whole system. It's very difficult, and that's the downside of it, of course. Yet you can achieve some kind of centralized management by using service discovery servers, by registering all the services which are running with a service discovery server. In microservice architecture, this is a common practice where you register all the running microservices with a service discovery server, so that it monitors what service is running, at what place it is running, at what port number it is running, whether it is running or not. And from this you get the various metrics, like the memory consumed, the number of requests being made to the services. So end of the day, you can centrally manage them. So even though in the previous discussion I say centralized management is bare minimal, but it's always a need. Without knowing what is happening in the system, it's entirely difficult to manage in long term, isn't it? So when somebody builds a real-time microservice project, of course few developers might have developed this, and a couple of team might have developed the third service, team members, and few members might have developed this. They developed it independently. Who developed this doesn't need to know even about this. Who developed this doesn't need to know even about this. They are developed as independent unit, but some point you have to make things available at one point. It has to be informative, right? So by using the service discovery servers, you get to register all the services that are running, and you get metrics about it, and you know what is running, where it is running, and what it is consuming, everything. So that's how a real infrastructure of a microservice architecture looks like. But it's the final thing. Once you deployed, once you developed everything, once you place things at places, this is how it looks like. But as far as a programmer is concerned, his concentration will be always on his service. He is trying to build a microservice. He has his own specific requirements, and he will be focusing on that requirements which is meant to be achieved this particular service. And whoever involved in this particular thing, they will be focusing on this. But somebody who overlooks everything might be knowing how it is going to be integrated, what a particular service does, right? But everybody involved in the system doesn't need to know everything about it. So it's very easy for us to bring in new team members, assign some tasks to them, ask them to do. In monolithic architecture, it's not. You need to transfer the knowledge before you ask them to do something, because they need to know the entire thing. Whereas in microservice, there is not a need. So just a couple of minutes. So I think by now you should have got some insights. Even though I'm not technologically into it, I'm just giving you a brief about it. So just few more things about it. We'll move into the practical stuff. by using a technology called Springboot. Without much delay, just 5 more minutes. I want to tell you few things, then I'll move into Springboot. And this is with respect to where a microservice can be deployed. It can be deployed on virtual machines, those whoever has the infrastructure idea for them. If you are not much into infrastructure, leave it, not a big deal. You can run them with containers, you can put it in public cloud, you can have your own devices, your own server, you can deploy it. So, and you have to understand, some microservices can be deployed here, some, that's what I was telling you 3 minutes or 4 minutes back. Some microservices can be deployed in virtual machines, some can be running in form of containerized container, some might have been deployed in cloud, but end of the day, all of them are able to provide or able to give a common solution which this fellow called end user is accessing. So for providing him one service or a big service, n things are working as independent unit, but that n things are not working at one place, whereas in a monolithic architecture it's going to be working at one place, whereas here it's split, and not only the logic is split but also the infrastructure is also split. Some of the microservices might be running at one place, some of the microservices might be running at other place. End of the day, it will be collaborated and it will be providing a final solution. And as I told, if this is disorganized, nobody knows the proper organization, right? That's why I'm using the word disorganized. If this is this much disorganized, there must be some kind of mechanism to at least know what is happening. That's why we use the service discovery service to know what services are running, and we try to get metrics out of it and we try to manage it. That is very, very essential in real time. Hope you got it. And before I conclude further discussion on this, just a few benefits and few anything. If you have advantage, obviously you will have disadvantage. If you want to get something, you have to give up something. So what you would get when you go with microservice architecture is, as we've been discussing right now, you have, it's just like repetition of what we have learned. You can use many technologies. You're not sticking to a single technological stack. You're not forced to do. You can do something with .NET. You can do something with Node.js. You can do something with Java. End of the day, you can call everything at one common place, and it works on single business capability, so there will be no confusions. And these are indivisible deployable units. So since it is a small unit, identifying problems in that particular unit is quite easier, and it allows frequently you can make releases because you don't need to put every work done by each individual at one common place, right? So since it is micro in nature, you can frequently release things. And security also, since you are targeting at a smaller level, you can manage it pretty well. And this is multiple services. This is what we've been seeing right from the beginning. Multiple services parallelly runs and deployed. And right side also, it is disadvantages. Don't get confused, it is not disadvantages. The whole slide is dedicated to only advantages. And what I'm trying to say is, it's scaled independently. You can keep on adding things, and same point is getting repeated here, but here this is important. Programmers and other technical resources can ramp up quicker by focusing on their specific microservice. So as far as cost is concerned, as far as quickness is concerned, as far as recruitment is concerned, I don't need to think while recruiting an employee that I need to pass him a complete knowledge of my complete services. No, you, since he is going to be focusing on one single thing or specific business logic which he wants to focus, you can quickly put him into work. And CI, CD and all we already discussed. These are the benefits, but at the same time downsides are also there. Since nothing is at one single point, since they might be at various places, since there will be constant communication between various things, because see, if a thing has to happen, since things are split at n places, this has to communicate with this has to communicate with this, maybe this has to communicate with this, maybe this has to, since there is a lot of communication involved, there will be network latency. That means to get an outcome, it will be a slight delay when it comes compared to monolithic architecture. So if there is a scalability, automatically what happens, latency will be reduced. If there is fault tolerance, even one microservice is not working, you say that I can it is not going to disturb other things, but what happens is it will be lacking security. And polyglot microservices, I mean, if you have multiple microservices written in various languages, team coordination will be very poor, because for example, microservice 1 depends upon microservice 2 that is written in .NET. This is written in Java. Suppose this guys wants to understand or comprehend something which is happening there, it is hard for them, because these guys don't know that technology, that guys don't know this technology. To coordinate, to make them mutually understand, it will be different, I mean very difficult. And if it is loosely coupled, sometimes there will be failure to respond to the request. We can discuss deep into it, but considering time, just understand outcome of loosely coupled is this: unless you are doing things in a well planned way, continuous delivery becomes a mess. That's what they are saying. So always distributed architectures are very hard to comprehend. That's what I told. Unless you understand the whole thing, or you manage it properly, it will be scattered at various places. Something which is scattered, it's always hard to understand. And you will never know how it is spread unless somebody tells you. And you find the various other disadvantages as well. I don't want to focus or waste time sticking each point, because we need to move on as time is running and ticking. Let's get into the actual technology part. So far what we have discussed is the idea called microservice. If you remember, in the first 5 minutes I clearly told that microservice is not a terminology which is related to a particular technology. It's a general term. Anybody can implement it, anybody can do it, any technology can do it. So for example, in Java technology, I just listed out few. That doesn't mean that only this. There are n things, n ways you can do microservices. There is a framework called REST, Drop Wizard, Vertex, which are of course widely used, but I would say the number one option in the market right now is Springboot. So by using all these technologies, you can actually build microservices. Not just 4, there are other technologies as well. And Node.js, the whole technology itself is actually follows the format of microservice, because everything you build in Node.js is an independent unit. There is no concept of web servers separately there. We actually build web services also with Node.js. The technology itself is a microservice based technology. And even in .NET Core also, they provide in the recent years they've been providing capabilities to build microservices, containerization, everything. So in .NET also it is possible to do. In Python there are frameworks like Nameco. This is a symbol of it, because Nameco means a kind of mushroom, so it's a mushroomy symbol there. And there is a framework called Flask, there is a framework called CherryPy, and there are other small frameworks also. Since it is open source, there are n frameworks in the market, but I would say one of the most widely used framework is Flask for building microservices. So in each technology we have similar options, but right now our discussion is focusing on this point called Springboot. So the next 20 minutes is actually going to be what is Springboot, what can be expected from Springboot, and how to get started with Springboot, what can be achieved with Springboot. But before we get into that part, all you need to register in your mind is Springboot is best for microservices. If you want to follow microservices architecture in Java, the go-for framework is Spring Boot. All right, so let's quickly start Spring Boot. So what is Spring Boot? So first and foremost prerequisite is, without knowing something called Spring Framework, one cannot aspire to enter into Spring Boot. So the prerequisite is, one must be knowing the idea of Spring Framework. There is something called Spring Core. There are core concepts like dependency injection, IOC inversion of control, IOC containers, and various ways of configuring dependency injections. So unless one knows the basics of Spring Framework, you should not aspire to learn Spring Boot, because that is primary prerequisite, and one want to get into Spring Framework. First of all, they should be very good at core Java at least. I hope everybody who is here should be understanding that part. And do I call it a development framework? It's debatable. Rather calling it a framework or something, of course it does almost all the jobs of a typical framework, but my point is, it's a simple idea. See, they themselves was given a switch button. There is something called as application. I want to make it as simple as possible, which is written by using Spring Framework. So you know Spring Framework, write something by using Spring Framework, and by using Spring Boot, all you're doing is you're starting it, you're switching it on, it runs. So Spring Boot provides a mechanism to start Spring based application, or to quickly run Spring based application. So what I'm trying to make out here is, Spring Boot is a technology which allows you to do standalone. So it automatically matches the requirement for microservices, isn't it? It is not dependent on anybody. It's going to be standalone. You don't need to deploy it in Apache Tomcat. You don't need to place it in JBoss. No, it is going to be independent. Second, it simply just runs, and what it runs? It runs Spring based applications. That has to be registered in our mind. So let's dig further into Spring Boot. What else? What else in the sense? Here few points, if you focus it fine, you can quickly jump into Spring Boot and you can do things of your own. All I'm trying to do here is just expose this technology for usage. Once you find how to go with it, automatically you can do wonders with the technology, because almost anything you can dream of can be done with Spring Boot. So first, you can create standalone application. Of course, that is a key functionality for microservice, you know it. And you don't need to deploy. If you don't need to deploy var files into some web server or application server like Tomcat, obviously you are not dependent on it, you are independent. So you become an independent unit, but still you need to listen to the request, still you need to do some server side operation. You can embed the Tomcat library or a Jetty library or Undertow library into your application. So instead of giving your application to the control of Tomcat, you take Tomcat library into Spring Control, run it, and listen to the request. That's how it is. And look at this word opinionated. What does opinionated means? See, in Spring Boot, the amount of code which you write is very minimal. For a task which needs 100 lines of code, maybe you can finish off with 10 lines. How this thing becomes possible is, for example, if you are doing some database operation, this Spring Boot automatically comes to an understanding, okay, this guy uses this particular library. If this guy uses this particular library, this is what he is going to do. Why he should program it? I'll do most of the repeated activities by myself. I'll ask him, I'll do 90 lines by myself. I'll ask him only to do 10 lines, which might be specific to his business. Whatever that is common to all the business logics, I'll write it by myself. That is what opinionated view. So for everything you do a mail functionality, you know what mail does. You need a from, to, and some message. So most logic will be already there. All you need to do is finally write some minimal logic. So already there are some starter dependency project in which we'll have the complete flow written. All you need to do is extend that flow. That is what we call opinionated starter dependencies. And you can easily configure Spring libraries, not only Spring libraries, third party libraries also. And as I told you, nobody monitors you. It's your responsibility to monitor yourself, but it provides libraries to monitor whatever you build, health checks, your configurations, your metrics. To monitor it, it provides library. Sorry, there is actually a starter project called Actuator in Spring Boot which lets you do it. And you do things with very minimal configuration. There is no XML at all in Spring Boot, and very few configurations you will be using, that too in a property file or a YAML file. So thing is, you build standalone services, standalone applications by using Spring Boot. The amount of code which you write in Spring Boot is very minimal, because you have to understand there are some things called as standard starter dependencies which knows what you are going to do already. So that you have to stick to the rules which is specified by the starter. If you are not following it, it is not going to help you, right? If you follow it, obviously you can end up writing only 10 to 20 lines of code for a purpose. So in short, Spring framework plus some embedded servers without configuration is what Spring Boot is. If you do Spring framework, you have to use web server, application server, where you have to deploy it, and maybe you have to use most annotation configuration and XML configuration to do it. But you do remove all those overhead and you go with Spring Boot. So naturally it fits into the rules of, or concept of, microservices. See, it has a wide variety of libraries, wide variety of modules. You can handle almost all kinds of databases, right from MySQL to Oracle to NoSQL databases like Cassandra to MongoDB to anything. You can deal with it easily by reducing a lot of code by using Spring Data. Most cloud related libraries like AWS, Azure, and service discovery servers can be managed by using Spring Cloud. And you can manage security by using the Spring security library. Why I'm marking those is those are very important. Other things can be there, cannot be there, but most processes will have this. That's why I'm marking this. Without Spring framework, it's not going to happen. And you do have other essential libraries also. Almost everything which you want to achieve for an enterprise solution is provided by Spring Boot. That's what I'm trying to make out here. So to create a Spring project, you can actually go for a cloud option in the sense you can actually create it online. Just last 10 minutes I'm going to show you practically how to do it, so that we can close our session. So online you can go to the Spring initializer site. You can specify whether you're going to go with Maven or Gradle to build your project, and you can specify the dependencies and you can create the project structure. That is one way. Or in your IDE itself you can do it. That is the second way. I'm not going to go with the first way. I'm going to go with the IDE called Spring Tool Suite, STS. It's nothing but an enhanced version of Eclipse itself. You can download it. You can simply search STS Spring Tool Suite. So you can download it for Windows, Linux, Mac, anything you want. I have already downloaded it. I have kept things open. let me quickly make you understand the whole idea so that you can taste the technology. So I'm creating a new Spring Starter project which actually creates, and you have to understand, since I told that Spring Boot has some opinionated view, you need to stick to their expectation. So if you want to stick to their expectation, the project structure, the dependencies, everything should be according to the specifications of Spring Boot. So to make you stick to the rules of the application structure to building to everything, they kind of build the projects only with some project management utilities. So they support two project management utilities to build a project. One is Maven, another one is Gradle. Of course, you can do projects with both the things, whatever you are comfortable with. Right now, I'm going with Maven, but you have to understand, if you want to go with Spring Boot, you have to do it either with Maven or Gradle, because your starter projects will get to know about your code only when you have a proper project management library. Otherwise, it will never know what you are doing, where you have organized. Since it is conventional in nature, it gives preference for convention over configuration. So you have to stick to the convention. If you have to stick to the convention, you have to follow the expectations of the framework. So I'm going with Java 8, not 11. And anybody who knows Maven should be knowing your project should belong to a group, and the artifact which we are building, that is actual unit which you are building right now, I call it my first app or first service. I call it com.service.first or com.first service. So this is the package name, and we do have a description for it. Here what you have to focus, see the current version of Spring Boot which is being displayed here is 2.3.3, and as I was telling about the various libraries supported here, see the amount of library support here. It supports starter projects for almost all the major databases. It supports various cloud libraries. It has libraries for AWS, it has libraries for Google Cloud Platform, it has libraries for IO, n things, almost everything which you could dream of in enterprise application development, it has support. So it's just like that, it's quite quick to grab things and do it here, but I don't want to go to complex things right now. All I'm going to do is I'm going to choose a dependency called web. I'm just going to show you a very simple straightforward REST service even without database, just to tell you how it actually runs and how it works, to introduce you to the technology. Once you are done with it, obviously when you jump into the technology, within days you can learn it, but the prerequisite, as I told, is one must be knowing Spring framework. That's the essential thing here. I have selected only one thing called Spring Web. You need to remember it. If you have selected other things, you might have got other dependencies. I'll show you in a minute. Let it configure. I would have pre-configured it, but my point is, the important thing is the application creation itself. So that's why I created it live. Oh my god. So meanwhile, let it happen. I don't want to waste the time. I'll tell you things how a typical Spring Boot project would be. See, I do have an already existing project as well. Meanwhile, it downloads the dependencies. You see, what we have done right now is Spring Boot starter web, and any Maven project, as most of people who are listening must be knowing, form.xml is the heart of any Maven application, which contains the entire details of your application, your plugins and your dependencies. Everything will be there. And Spring basically runs on the starters, and every Spring Boot project will have a parent project. Here in this case it is starter parent, and while I was using that project, version was 2.2.4, but we do have a recent version right now. And we do have other starter dependencies. Once you mention all these dependencies here, you get the structure. And a Spring Boot application is basically a core Java application. See, all it has is public static void main. As I told you in the theory, you just run an application, you have the code for this application, various packages are there, security is there, services are built, everything is built there. All you are doing is triggering that application at one point. Once you trigger it, every other package is integrated here. See, com.boots.star is integrated, I mean every package is integrated, and you have database repositories, you have entity classes integrated here. Since the whole Spring application, whatever you have built, is integrated here, all you're trying to do is trigger it and run it. So this is kind of big now, kind of overwhelming, so I don't want to get into it. Luckily, I think the project creation is getting over. Yes, so I'd open our new application just in a matter of minute. I'll show a sample application. It might not take even 5 minutes, so that you can understand how it really works, so that we can properly close the stuff. So we got the structure of it, and you have to understand Spring Boot goes with minimal configuration. So suppose if you want to run your application on a different port number, by default it is 888080. If you want to run it on a different port number, you can run it. So for this kind of minimal configuration, you use a file called as application.properties, which will be under resource folder. And you have to understand, you are not placing your code under any server. When you put the dependencies called web, automatically you get a library called Tomcat embed, which will have embedded version of Tomcat. That means your application is going to call Tomcat automatically, and automatically you do have beginning of your application is actually called demo application. I do create a project, I mean simple package. com.first service dot start everything under it. So all I'm doing is I'm creating a new class called first controller. As I told, I'll just simply create a very small REST service. So to create a REST service, all you need to have is a REST controller and Spring. And I'm going to accept request from the client, request mapping. Let us assume that all the requests are starting with an endpoint called API, and somebody makes a get request. So there is an annotation called get mapping. Let me call greet. The function name can be anything. It will run automatically when somebody makes a request for API slash greet. What I'm going to do is greet. And very quickly I'm creating an array. I also create one more endpoint just to make you understand how easily this framework converts arrays into JSON objects without any need of changing things. See, I want to call it people, and let me call the function also as people. And here what I'm going to do is I'm going to return a string array. All I'm returning is en. See, it's very simple. All I have done is we do have a core Java application here, and it is telling that the controllers can be checked in not only controller services, everything. If you know Spring, you must be knowing to scan the packages here. I have only created a controller, the to REST controller. So if the request is for API, and if you are giving the endpoint as greet or people, we do have the appropriate code here. So let us try to run this by right clicking this demo application, run as. I told you this is a standalone application. So either run as Java application, run on server is not the option because you don't have any server explicitly here. Since look at the output, so it's showing up what is running, and see there is no any error or exception, and I haven't even specified the server, I haven't specified or I haven't deployed my application anywhere, but automatically the server started, and the server is under the control of the Springboot application. It just started the listener, and it also took this setting called server.port 8899 and it started in it, and somehow it would have triggered the whole application from this point. Since we have controller which is waiting for a request from this URL, you can probably go and check in the browser localhost 8899 if I'm not wrong. It's running in the port number 8899, right? API slash greet. Say Springboot is running. It's as simple as that to trigger an application, to create, build an application. It becomes a standalone application, and the second endpoint is people, right? So it automatically converts. Nobody needs to say. It automatically converts into a JSON object directly. Here it might sound similar to you, but the point is, if it is an employee object or something, automatically it gets converted into JSON. You don't need to even use any external library or external converters to do it, because Spring Boot is opinionated in nature. You have to go with minimal configuration. It does things of its own. So as we proceed, database operations and everything is quite minimal in Spring Boot. It's quick to build and quick to develop application. So I think we are running out of time. I just want to conclude our session. Thank you for being part of it. And one last point I want to do is, once you're finished with your application, all you got to do is you can probably go for a Maven build. You can give a specific goal like packaging your application. What happens? That's what I wanted to say. It will try to build your application. If you have any unit test cases, it will run it. I need to configure JDK rather than JRE, but my point here is, you have to understand, once you build your application, a jar file will be created. You can take that jar file anywhere to any system. You can run it anywhere. I can probably configure it and do it, but taking time into consideration, I just want to end this session on a good note. So all we have done is, we have explored this technology or an idea called microservice, and what are the capabilities of microservice, pros, cons. We discussed everything, and we kind of seen Spring Boot is capable of doing almost every kind of enterprise operation by sticking to the expectations of microservice. That is very important. So all I tried to do here is to introduce you getting started with Spring Boot. So everything which we discussed about microservice can be achieved with this help of this technology in Java called microservice. But the only prerequisite to get into this technology is one must be very good at Spring framework. Thank you for being part of it. Hope you adventure with this technology. Thank you all.